Most teams don't learn this lesson until a painful event with their CFO, where their CFO comes at them with a 5, 6, or maybe even 7-figure observability bill. Don't make this mistake. Hi, I'm Jack Neely, and I'm an independent observability architect and owner of Cardinality Cloud, LLC. I have 25 years of experience in DevOps and observability work, 13 of those years as a subject matter expert in observability. I want to use this YouTube channel to share with you what it's taken me 25 years to learn. Today, that's going to be about logging at the crawl stage. Remembering my crawl, walk, run framework that I'm setting up, logging at the crawl stage is just getting started with a new application, a small startup or a small AWS footprint where you just need to have logging and have it working. Logging is table stakes. You will have it as you develop your application. So it's important that we figure out how to deal with those logs well at the beginning. Your future self will thank you. A common question to ask at this stage of the game is, well, what fancy logging tool do I need to store and analyze my logs in? And I've done the math. In fact, let's look at the math. This is a graph that is a model that I created to figure out how expensive various options are for dealing with logs at various stages of the game in the crawl, walk, run framework. And I consider the crawl framework to be anywhere 1 terabyte per month or lower. That's 35 gig a day. That's not a bad amount of logging. It's not a super lot, but that's a reasonable amount of logging. At 1 terabyte per month, all the solutions are really pretty equivalent as far as pricing goes. So this tells me that what we should focus on is our technique and our habits, and that the decision of a tool to use is really a distraction. Focus on your application, not the fancy logging stack. If you're in AWS, you have CloudWatch. It works. It's as cheap or as expensive as just about anything else at this level of the game. One thing I want to specifically point out is that when we're developing logging and centralizing those logs, we want to be really careful of network costs. In AWS land, this is the DTO, data transfer out, and NAT gateway charges, which can build on top of each other. This can make logging just about as expensive as some expensive vendor. So we want to be careful about those network costs as well. CloudWatch avoids the network costs. Let's start there. What matters? The logging habits that we establish now are what matters. Let's look at the mindset that you should adopt as you deal with logs for the first time. Logs are data. Always treat logs as data. They're there for a machine to read, a computer program, an AI agent, and it's also really handy if a human can read them too. Logs are immutable. If you didn't mean it, don't write it. Logs are standardized and schematized. This is an incredible boon for being able to parse logs and feed them into an AI agent and not completely burn up your tokens with your AI service. Logs are always leveled. This is the error, warning, info, debug tags that we associate with each log. Make sure that all of your logs are leveled and try to develop a consistent pattern across all of your applications. Make sure you document your decisions as far as which tooling you're using, which logging libraries, that schema that you use, just like you would document any other architecture decision in an early startup phase. If it's one thing I want you to walk away with from this episode, it's the idea of a canonical log. Now, this dates back to a blog post from Stripe from some number of years ago, where they define a canonical log as sort of the authoritative one-line, one-entry log that is produced per transaction per API hit. So the application can log as much debug or error information as it needs, but for each API, there's that one authoritative summary of the entire transaction. This reminds me a lot of working with Apache and Nginx, where every single time you hit an Apache server, you get a log in your log stream that says what URL you hit, what was the status code, the user, the IP address, how many bytes were transferred, and it's in a well-known, well-understood format. Apache can log a bunch more other stuff, but that canonical log per transaction ends up being what we keep and use the most. Things to be careful with: setting up logging. Don't log source code. Don't ask me how I know. Don't log source code. Don't log any sort of secret you might be dealing with. Passwords, authentication tokens, browser credentials, AWS credentials, private GPG keys. Again, that classifies and don't ask how I know. This also includes government identities, any sort of government issued identity. Any bank numbers, routing numbers, credit card numbers. Definitely want to make sure these are not in your logging stack. What I want you to be aware of as you start your logging practice is the idea of personally identifiable information, or PII. This probably isn't a crawl level topic, but you want to set yourself up for success. And this is the idea that a username by itself doesn't identify a whole lot, but we're doing logging here, so each log has a timestamp. If we have a user ID in that log, and perhaps an IP address where that come from, well, now you're tracking your users. You know exactly where a user is because you can geolocate that IP address, what user and what time they were there. So those three elements together create some implications for your data that might be important, especially if you're under GDPR or have other compliance issues. And the solution there is being able to mask important fields like the user ID. Again, not a crawl level subject, but with structured logging, you're set up for success in dealing with that in the future. I want to introduce you to the search method that I use. When I'm building a logging stack, configuring logging application configuration, logging libraries, I will definitely try to make sure that the configuration I create is available for all of our teams to use as part of their standing logging practice. When I'm thinking about this, I use my search method that I created to help me remember how I structure logs and what's important to be in them. You can use it too. So that's S for schema and structure. Your log should be schemaed, usually JSON, a flexible schema that can be added to, but don't forget to make sure that all teams agree on some of those important fields like IP address and username. E is for errors. Make sure your errors are logged appropriately. A lot of logging libraries have a neat little trick to log errors in a similar format and have an error ID or error hash with them. This lets us be able to track similar errors across our entire stack. That's a really handy trait. A, audit the action. Did you read? Did you write? Get? Put? Post? R, resources and users. This is the what we acted upon. What user, what website, what page, what API did we use in this transaction? C is for status codes and log levels. Just like your HTTP status codes, those are important to include in your log message. And of course, don't forget your log level. Log levels are critical. Finally, H for human. Every log message should have a human readable message part of it. I would suggest use the message field for this. And this gives us a great ability to be able to display timestamp, service, and human readable message so that when we're debugging stuff, it's easy to figure out what to look at and where to dive deeper. Again, logs should be a JSON format. They should be schemaed and structured. Use the OpenTelemetry semantic convention for logs or the Elastic Common schema for ideas and inspiration about how to structure your logs. The logs don't need to be very rigidly structured. If somebody needs a new field, let them do it. but make sure that common fields are common across your entire application stack as much as possible. This example on the screen shows what a log message should look like. It should be parsable by JQ. JQ is going to be able to display your log file in a really easy to read structured format. In fact, you can use JQ to pull out the timestamp and the human readable message part and display that easily on screen. And there you have a perfectly useful way to analyze and search your logs at your terminal. One thing I want to point out is that adding JSON structure to your logs does add more bytes to your logs than just raw unstructured logs. So the vendors charge by the byte. How do we balance this? Well, the benefits we're going to get from structured logs are vastly going to pay for themselves very quickly. You're going to get benefits out of structured logs every time you build an alert, create a dashboard, investigate a problem, save some AI tokens in your AI agent when you analyze these logs with an LLM. And the structure is going to be vastly, incredibly useful. What we can do to balance things out is to make sure that we use shorter field names. We might use MSG instead of message for that human readable message. Also, of course, when you're transmitting across the network or you're storing logs in S3 or wherever, turn on compression. Don't forget that part. So this is the lesson that teams have a hard time learning until a painful event happens. I want you to learn this lesson first, how to start off well with your logs without having a bad encounter with your CFO. If you want somebody to help look at your logs before your CFO does, or explain the big logging bill to your CFO, or figure out how to best set up your logging before that bill comes, that's what I do. See my link in the description below.